Astronomers have discovered a new radio galaxy named J011 plus 3217 using the low-frequency array LOFAR. This galaxy exhibits unusual features, including a one-sided secondary lobe. The finding was reported in a research paper published on June 21 on the arXiv preprint server. Radio galaxies emit large amounts of radio waves from their central cores. The black holes at their centers accrete gas and dust, producing high-energy jets that accelerate charged particles to high speeds, visible at radio wavelengths. A typical radio galaxy during its active phase lasting up to 100 million years includes features such as a core, lobes, jets, and hotspots. After this phase, when the active galactic nucleus AGN shuts down, the galaxy enters a remnant or dying phase, and these activity markers usually fade now. A team of astronomers led by Shobha Kumari from Midnapur City College in India has reported the detection of such a radio galaxy with lobes. The researchers wrote in the study, from the second data release of the LOFAR 2-meter sky survey LOTS drive to at 140 MHz, we identified a peculiar radio galaxy, J011 plus 3217, according to the paper. J011 plus 3217 is a giant radio galaxy with a one-sided secondary lobe and misaligned large primary lobes. The newly discovered galaxy appears to be associated with the Abell 7 galaxy cluster. LOFAR observations show that the secondary lobe has a linear size of about 2.77 million light-years, approximately 85% of the primary lobe's size. Such one-sided secondary lobes are extremely rare, with only a few previously discovered in some X-shaped radio galaxies. The astronomers highlight the large size of the one-sided secondary lobe in J011 plus 3217, as these features are typically 4 times smaller than primary lobes. Therefore, a giant, one-sided secondary lobe like the one in J011 plus 3217 has not been observed in other X-shaped radio galaxies. The study also found that J011 plus 3217 has minor distortions or off-axis deviations. Such bending in the jet is more common in wide-angle tail-watt radio sources, which are powerful, bent radio sources usually associated with the dominant galaxy in a cluster or group. The paper's authors emphasize that further studies are needed to fully understand the characteristics of J011 plus 3217. Further studies, including simulations and optical follow-up observations, will be encouraged to measure detailed parameters and investigate the conditions under which this peculiar radio galaxy, J011 plus 3217, formed, the researchers concluded.